Hello dear go-getters, I just hope you're doing well. So in this video guys, I'll be doing this kind of a question there, whereby you are given this question there. In the diagram below, trapezium QHFS is drawn such that QH parallel to SF there. So there you are told that this length of QH is parallel to SF there. So a key thing that you should understand guys about parallel lines is that if QH is parallel to SF, it means that the gradient of QH is equal to the gradient of what? Of SF there. That is the key thing that you should understand about this question. So the first question will say now determine the gradient of SF there. So in order for you to get the gradient of SF, you should use the gradient equation. So these are the points that were given in F3. So here we can name this one as point 1, this one as point 2 there. Remember, you don't name your points like this here. You can't name like this there. If you do such a thing, this thing is already wrong there. So this equation is the equation that you should use for you to get a gradient there. So I can use that equation, say y2 minus y1 divided by x2 minus x1. So now I can substitute here. And then here I'm talking about gradient of SF. So when I substitute that, this thing is my point 1 there, which is that one, it's my point 1, which is x and y. Here it's x and y there. I'll say x and y there. But a negative number, you put it inside the brackets, just like that there. And this one it's point 2, which is x and y. Here it's x and y, meaning here you can say x and y there. Then you can use your calculator guys to press this thing. Then you can use your calculator, which is there, you'll say 0 minus 1 and divide by 3 minus 0 there. Press this thing there on your calculator so that you will get 1 over 3. Meaning here your gradient of SF will be 1 over 3 there. Do you see? Yeah. Or that answer there, you can even write it in decimal form there, which is that one, it is in decimal form, which is 0.3, like that there. So if you can take a note there, your gradient there is positive, by the way. Even the line, the way it is, it represents a positive gradient there. Do you see? I told you that if a line there is positive, it must be like this there. When the gradient there is positive, it means the line must be like that there. Do you see? So here, this is the gradient of this line there. And now the next question now, symbol say now to you, determine the equation of QH there. They need you to determine the equation of QH. And a key thing there that you should understand is that for you to know the equation of QH, you should know the gradient and know the y-intercept of that line there. But if you can take a note there, we don't have a y-intercept of this line. So that y-intercept there, we should solve it. Let me talk about a gradient there. I already told you that these two lines, they are parallel. So these two lines guys are parallel to each other, meaning that their gradient there is equal. So its symbol says that the gradient of QH is equal to the gradient of SF there. And the gradient of SF is the one that I just got it here, meaning that the gradient of QH will be 1 over 3. Do you see? So now what I will do, I will substitute from this equation the gradient, because I already know the gradient, meaning that equation now will become like this now. Do you see? So now I should solve that C. For me, guys, to solve that C, I will take one point there that I will substitute it here, so that I will have that C as my unknown value there. So there you can take any point on the line of what? Of QH there. This is the line of QH there. From that line, you will take one point that you will substitute it there, so that you can solve for C. Meaning that point there, it is point what? H there. 4 and 4. Whereby you got what? You got your X value and your Y value there. Then we'll substitute that point there. Substitute here your Y value and substitute your X value there. Do you see? So then now this is what you will do now. You will solve that C. We'll start by pressing this thing from your calculator, which is 1/3, 4. So it means that this thing will be 4/3. And here it's 4, say, plus C there. For you to solve that C, guys, you can take this thing to the other side, a number to a number. Meaning that it's 4 minus by 4. So meaning that I'll just say 4 minus by 4/3. This is what I will get there, which is that it's 8/3 as my C. So Simul says that the value for C there, it's 8/3. Which is, guys, 8/3 there. If you can press SD, that 8/3 is the same as 2,67 there. That one. Do you see? So now your equation, now it will become like this one. It's your equation. You know the value of C there. The value of C, you know the value of M, which is a gradient, which is 1/3x. And now you know the value of C, which is 8/3 there. You can leave your answer like this, or you can leave your answer in decimal form there, which is 0,33, whereby this thing there, whereby this one there will be 2,67 there. But what I will suggest you, that leave your answer in fraction form if you are dealing with the equation there. If you are dealing with the equation, just leave your answer in a fraction form there. It's not necessary for you to leave it in decimal. It's not necessary there. So this is how, guys, you identify the equation. The first thing that you should know that it's a gradient. Then you substitute the gradient. Then you'll take one point on that line, substitute that point, then solve for C there. Do you see? Yeah. So now let's go to the next question then. Here's the next question now. Simul say now, calculate the value of K. Where is the value of K there? Here's the value of K, guys. There. Do you see? That K there, you can solve it in many ways there. Since now you know the equation of what? Of QH there. So this is how I can solve that thing. I know the equation of that line, and say plus 8/4, 8/3. And that point there, it is equal to K and 2 there, which is here, it's my X, that one it's my Y value there. So it means that I should solve my X value there. I already know the Y value there. Do you see? This one. So now I should know my X value there. So this is what I will do there. Where there is Y, I'll substitute 2 plus 8/3 there. So now I have to solve that X there. For you to solve that X, take this thing to the other side. That thing there will become minus 8/3, 1/3x. Then I can use a calculator of saying 2 minus 8/3. This is what I will get there. As you can see, I hope that you can see this thing. So I'll get negative 2/3 there. Yeah. So I'll get negative 2/3 there, meaning all of this thing there will give me negative 2/3. And here, this thing there, it's 1/3x there. Do you see? So then now, what you should know is that that x, guys, will get multiplied upwards there. because here we got invisible 1, that x there will multiply upwards. That equation will become x over 3 over that thing there. Then now you can do your cross multiply, meaning this will multiply here, that will multiply there, meaning this thing there will be 3x minus 2 multiplied by 3, which is this thing giving me minus 6, 3x there. Then now I can divide there, divide, meaning now this will cancel, x there will become minus 2. You can even apply this approach, guys, the one that I was doing from that previous video, whereby I know that these two graphs, they are parallel, those one. QH is equal to this one there. And now I know the gradient of QH 1 over 3 there. And what I know there, I know that Q there, which is K and 2, and I know H there, it's 4 and 4, which is this my x, y, 1, 1, 2, 2. So I can even apply the gradient equation there, which is this one. It's a gradient equation, QH 1, 2 minus this divided by x2. Then now I can substitute this thing, it's 1 over 3 there. So my point 1 there is that one there, where it is k and 2, x and y there. And this one is point 2, which is x and y. So now I have to solve for k there. Do you see this thing? So now I have to solve for k there. So now when I solve that k there, this, when I press on calculator, will give me 2. This one there will give me 4 minus by this thing, 1 over 3. Yeah. So now what I can do there, I can do cross multiply, meaning this will multiply there, this will multiply here. This will be 4x and 3 minus by 2, which is this thing that will give me 6. And here it's 4 minus k. Take that thing to the other side, so that thing there will be what? This minus x there. Do you see? Whereby here I'll get minus this, and what is in front from what I need, I divide by it, meaning that I will divide by -1, so that this will cancel there. Then my x value there will become here supposed to be positive there, become -2. Do you see? Yeah. So it's up to you guys, which approach do you prefer to use there, this one or this one. Then if guys you use this one there, you solve that x there, and that x there is the same as k, so you can conclude therefore k there is -2. So there are many ways to kill a cat. It's up to you which way do you prefer to do this thing. Yeah, this method you apply it only if you see that those two lines are parallel, meaning that the gradient here is equal to the gradient there. And now since you know the gradient, it means you can apply the gradient equation, substitute the gradient and substitute the point, then solve for k there, just like that.